Hi everyone, I'm David.
Hi, I'm Hal.
This is Professor Hal Abelson. We are in his office in the C-Cell, the Data Center in the MIT. And we're very glad to have a brief talk with Dr. Hal about the new coming App Inventor features in 2018. So I'll have some brief questions for you.
Sure.
The first one is that we know there will be some new features of App Inventor, like iOS new platform and the new rollout component like Map and CloudDB. Can you introduce that for me?
Well, that's what's coming.
Hmm?
Well, App Inventor is growing very rapidly, and also what's growing very rapidly are the way people want to use mobile phones. So we've been extending the capabilities of App Inventor with a lot of energy over the last year. The biggest one, of course, is extending it to iOS, because there are a lot of people who want to use App Inventor for building things for iPhones and the whole Apple infrastructure. But there are other ones too. One of them that David just mentioned is Maps. People have wanted to use Maps in App Inventor for years, and we've had a very limited kind of Maps component. But that's not good enough for what people want to do with phones these days. The other one is the whole architecture of extensions, which is already being used. There are lots of other things that you can do with App Inventor by making little extensions that you write in Java, for example, multi-touch. But the big one we're doing is connecting that to Bluetooth and all kinds of IoT devices. So what we're doing at MIT is, rather than making one particular IoT device, we're trying to make it so that people can adapt them to use any device. So that's another big thing we're doing. The other thing that's really important for teachers is collaboration. So people know that if you're editing Google Docs, for example, you can have several people editing the same doc simultaneously, and that way they can work together. Well, the same thing with App Inventor. We can have several people modifying and creating blocks simultaneously so that we can do collaborative projects. We think that's going to be very important for using App Inventor in education. And then there are other things that we're working on. The other very large open area is artificial intelligence. So the next generation of smartphones, even now, are all going to have neural network circuitry in them. And the question is, what are the projects that kids and everyone can do if they can use neural networks? So we're working on extending App Inventor to include some of those capabilities. It's going to be a very exciting year with the new things coming out.
Okay, I think Hal have already answered my question 1 and 3. And my next question is about, because in the education area, people nowadays, they are talking about computational thinking. And I think App Inventor has a very strong relationship with computational thinking. Can you talk briefly about that?
Well, sure. I mean, App Inventor comes out of a tradition started at MIT. The genius who started that was Professor Seymour Papert, computer science professor, who started talking about this towards the end of the 1960s and started what's called the MIT Logo Project. Well, the Logo Project is what I worked on when I came to MIT as a graduate student in 1969. And our attitude there was, what was important is not the mechanics of programming, but the way you can use programming as a tool for understanding things. And we invented something called the Logo computer language, which was one of the first computer languages designed for use by kids. And the idea was that if you wanted to understand things like mathematics, for example, one very good way to understand them is to write computer programs that manipulated things. That's a very common attitude today. But in 1969, 1970s, people thought we were crazy. The idea that that children could program a computer was just considered outrageous, because computers cost millions of dollars, and they were used in the United States by the military and by very large companies. But gradually, computers got smaller. Kids were able to use them, starting with personal computers in the 80s, and people went back to the ideas that Papert was talking about at the end of the 60s and called that computational thinking. Some of the very big ideas of computational thinking are the notion of what's called abstraction, that you describe things at a very high level of detail, and that allows you to manipulate them better. There's ideas such as modularity, which says you put things together in pieces. And then there are a few ideas that are special to computers, like sequencing and parallelism. So that's all become very, very popular today. People talk about computational thinking. For myself, I think there's been a new phenomenon that's happened maybe in the last 10 years, which is it's not merely that children can write computer programs to understand things. It's that children can write computer programs that actually have impact. So you can write something where you can send messages to thousands of people, or you can write a program that's going to be used by not only your friends, but everybody's friends. And we call this computational action, that the computing infrastructure has grown to the point where even children can write programs that have real impact on their families, on their community, maybe even on their country. And one of the things when we think about App Inventor, we stress this computational action. And the thing we are most proud of at App Inventor is when we see kids doing things that actually have an impact on their community.
Okay. These years when Asian kids, because you know Asian kids are very competitive in their way of getting colleges. So, but in Taiwan we are going to teach programming from this September as a whole country.
Oh, that's terrific.
Yes. For the primary school, we are mainly using Scratch. Mm-hmm. But maybe higher grade, higher level, higher grade, we're using Scratch, using App Inventor, combining with other physical devices like Arduino or Lego devices. So let them to have some remote control projects. I think App Inventor is a very good platform with that.
Well, I mean, App Inventor is a good platform for combining with other devices, but the other issue with App Inventor is that you can make real applications that do sophisticated things. Scratch is wonderful too. It is more limited to doing animation and media computing on the screen. Mm-hmm. But App Inventor is a very general programming language. So if you want to look at anything that computers can do, you can do simple versions of that in App Inventor. So I think the appropriate thing is to start with Scratch, so people get some idea of what's going on with computers. But at some point, children want to do something more ambitious than just making video and media things that they interact with, and they want to do a much more general kind of program that actually has an impact of something. And that's an important time to switch to App Inventor.
Mm-hmm. Okay, and I was here as a visiting scientist since last October. I remember that's a quite long process for me to be here, and I'm also very happy to be here. Every day here is very interesting, exciting, and happy. And in the future, how will App Inventor to have more interaction or have more cooperation, like with other group or institute like KV Education?
Okay, well it's first of all, it's wonderful that you've been here, David. You've really added a tremendous amount to the project. MIT is we're not set up to take large numbers of visitors. So it's very, very difficult and complicated to become a visitor in our group physically at MIT. What we are starting is we're starting an App Inventor affiliates program for organizations that want to collaborate with MIT. So we're just launching this, and places will say they want to become an App Inventor affiliate, and that becomes a basis for doing joint work and joint promotion. So that's the way that I'd say organizations can start collaborating with MIT around App Inventor.
Okay, I think finally, because Hao just told me that App Inventor's user, Taiwan App Inventor users, has about 8% to maybe 12% of the total App Inventor users. Then since this is just over the Chinese New Year, maybe Dr. Hao can say some encouragement words to Taiwanese App Inventor users like kids and parents and teachers who are using App Inventor.
Oh, sure. So first of all, I think if you look at all the countries in the world in terms of the number of App Inventor users of our MIT system, Taiwan is number 4 right now. So that's quite remarkable. 4 among all the countries in the world in terms of how many App Inventor users there are. I think we're at the verge of a real change in what's possible with computing. People look back and say, oh, over the last 3 years, over the last 5 years, there's been enormous change and suddenly people are interested in computing. But I think that's nothing compared to what's going to be happening over the next 10 years. If you look at the power that's happening around artificial intelligence and machine learning and the power of connecting things on the internet, it's just impossible to predict even for 3 years what will happen there. If you look at all the things that are around now that people are using, you find that many of them didn't exist even 3 years ago. And then in terms of education, if you look at a kid who's 15, age 15 right now, and you say, what's it going to be for this kid to know and have ability with when they're 20 years old? You almost can't predict it, but you do know they're going to have to know something and have some kind of capability when it comes to computing and computational thinking and creating programs that actually matter. So I'd say I can't overemphasize how much I'd encourage kids knowing about this. And that should be obvious to anybody who thinks of the way technology is going. So I really applaud the fact, as you say,